What's up, guys? And today's video is on atomic structure. I need to get through these flashcards for chemistry. As you know, chemistry, aka A-level chemistry paper 1, is on Tuesday. Very close. So what I've done is I've created this with all the year 2 equations you need to know, all of them for the paper 1, and obviously the observations. So like 95% of this is just reaction metal equivalents and transition metals. And hopefully, because I've put it all on one sheet of paper, inshallah, I'll help you memorize it and I'll go through it with you guys. Maybe create some YouTube shorts with that. But today's video is going through some flashcards and getting rid of some which I think are not so useful. So equation for electron impact, equation for electron spray. Electron impact, well, it's going to be xg plus h plus to xh plus. No, that's the electron spray. This one's xg arrow x plus g plus e minus. An example of a drop between group 5 and 6. Phosphorus and sulfur. Sulfur is a double occupied paired electron, the 2p. Electron being removed from single occupied in p. Electron being removed from orbital contain 2 electrons, pulled between 2 electrons orbital. Electrons easier to remove. Example of drop between groups 2 to 3 showing subshell structure. Aluminium's outer electron 3p orbital rather than 3s. 3p orbitals higher in energy further from nucleus. Okay. Why does ionization energy increase across period? Well, the nuclear charge increases, hence the number of protons increases, and similar shielding and the same number of electron shells. Similar shielding, all extra electrons are at the same energy levels. Why does ionization energy decrease down group 2? Ionization energy decrease down to group 2 because the group 2 become bigger. Group 2 metals become bigger. The outer electrons further away from nucleus, and extra shielding, and each element down group 2 is extra electron shell compared to one above. Perfect. Big jumps in ionization energy happen when an electron is being moved from a shell close to the nucleus. Successive ionization energy increases in each cell, with electron being moved from increasing in positive ion, therefore less repulsion amongst electron held stronger by nucleus. A graph of successive ionization energy show evidence for cell structure of atoms. Again, like this one, this is really, it really is a pointless flashcard. It's good for your understanding, but like in terms of questions to ask you, never ask you what this means. So again, I'm going to get rid of this one. Obviously, this one is very important. Definition of second ionization energy. Everybody knows the first one, but do you know the second one? Definition of second ionization energy is energy needed to remove 1 electron from each ion and 1 mole of gases 2 plus ions. 1 mole of gases 1 plus ions to form 1 mole of gases 2 plus ions. So let's go for it again. Energy needed to move 1 electron from each atom and 1 mole of gaseous ions. Yep, 1 plus ions in order to form 1 mole of gases 2 plus ions. First ionization energy needs to remove 1 electron from each mole and 1 mole of gases 1 plus ions. Perfect. Why is the first ionization energy endothermic? Because it takes energy in to ionize an atom. Yeah. A key fact about ionization energy, I know what it is, but I can't explain it. The lower the ionization energy, the easier to form an ion. Perfect. So that's exactly, I was like, I can't, then you have to dig deep in your brain and find what's going on. Nuclear charge. Again, this one is more proton nucleus, more positive charge, stronger attractive electron. I'm going to keep this, but I will get rid of it eventually. Shielding. Number of electrons between outer electron and nucleus increase outer shell. Electrons will feel less attraction towards nuclear charge. Distance falls off rapidly with nucleus. Electrons are further away from nucleus, feel less attraction towards a positive charge of nucleus. Transition metals, I don't know why I wrote this, but they have, when they become ions, they lose 4s electrons before they become 3d electrons. Chromium and copper behave unusually because they have either a full or unfull 3d subshell. They donate one of the 4s electrons to 3d subshell. The two metals that behave unusually under electron configuration, chromium and copper. Electron configuration, you don't necessarily need to memorize it, but I guess it could be useful. The key fact about principal quantum number. Further shallows from nucleus, highest energy. Wasn't that just exactly what I put in before? Sorry. Electron close to the nucleus, no. You don't need to know this larger principal quantum number. You do not need to know this. And I'm actually just going to double check for you guys right now on my phone. My other phone. Because, also guys, while I'm doing this, don't think like, oh, there's only a couple of days left. It's too late now to revise chemistry. I promise you it's not. If you've done no revision at all and you know nothing, the best thing to do is probably past paper questions. I'm not saying it depends how much you know, but if you know nothing, then probably past paper questions because they love to repeat them anyway. Okay, I'm just having a quick look, and there is no mention on principal quantum number. So again, just something the textbook decided to introduce that was not necessary. Molecular ion, M+, form a mass spectrometer when one electron is removed from the molecule. How can mass spectrometry be used to identify molecules? M+ form mass spectrometer when one electron removed gives a peak. Okay, the y-axis mass spectrum is the abundance of ions, x-axis is the mass/charge ratio. What is the mass spectrum? Mass/charge plotted against abundance. Electron impact ionization. Electron impact sample. Sample is vaporized and electron gun is used for a high energy electron, knocking one electron off each molecule, becoming 1+ ions. Perfect. Electron spray, sample is dissolved and pushed through nozzle at high voltage, high pressure, high voltage. Applied to it, causing each bottle to gain a 1+ ion. H+ ion. Then samples may turn into gas, may deposit ions. 4 stages of time of flight mass spectrometer. Ionization. Ionization. I just want to get in the correct order, so let's go through. Ionization, acceleration, ion drift, and detection. Okay, relative molecular mass. The average mass of a molecule on a scale, an atom of carbon 12 is 12. Relative isotopic mass. Mass of an atom of an isotope of an element on a scale, one atom of carbon 12 is 12. Mass number, the number of protons and neutrons in the nucleus. Atomic number, total number of protons only. Label A, Z, and X and how to find number of neutrons. A is your mass number, Z is your atomic number, and to find your number of neutrons, it's your mass number minus atomic number. Why do isotopes have slightly different physical properties? Different densities, physical properties depend on mass of atom. I'm going to keep this. I could see them using it as a 1 mark. I don't know why I could see that. John Dalton described atoms as solid spheres. Outside different. Again. With the atomic structure, like the history of it, the specification is very broad, but they would never. Because if I have a look at the specification, again, they would never ask you specifically about John Dalton. No, people they would ask you about J.J. Thomson, Ernest Rutherford, and yeah, that's maybe Niels Bohr, but never ask you about John Dalton, so therefore I'm going to get rid of this because that's just a pointless flashcard again. J.J. Thomson, now you do need to know J.J. Thomson. J.J. Thomson discovered the nuclear model, or discovered the electron, and he showed atoms weren't solid and indivisible. Solid sphere idea changed plum-bloody model. Ernest Rutherford, gold-foil experiment. Fired positively charged alpha particles at thin sheet of gold. The plum pudding said most alpha particles will be slightly deflected by positive pudding, but most particles pass straight through gold, only a small number deflected backwards. Again, this came up in GCSE, Ernest Rutherford, so I would learn that. What did the results from Ernest Rutherford gold experiment lead to? The plum pudding model was wrong, therefore Rutherford developed a nuclear model of an atom. Nuclear model of an atom, you've got a small positive nucleus surrounded by negative electrons. Tiny positive nucleus surrounded by a cloud of negative electrons. Atom is mostly empty space. Scientists realized about cloud electrons and cloud Ernest Rutherford that electrons in a cloud around nucleus quickly spiral down the nucleus, causing atoms to collapse. Niels Bohr proposed the new model of atom. Again, Niels Bohr, no. They would never ask you this. Maybe it's useful to know what he proposed, a new model atom where electrons can move between shells. And electromagnetic radiation is absorbed, but they would never ask you this. So that's atomic structure, and I think atomic structure is one of the most tedious topics to go through in all of A-level chemistry. Well, all from paper 1. So now we're going to be on a roll for the next couple ones. And again, same thing with these what I just did right now. Flashcards I think are useless. I'm going to get rid of.